This video is going to cover the 10-7 warm-up and then the chapter review for the chapter test, which is this week. So we'll start with the 10-7 warm-up. If you haven't already, pause the video, allow everybody about 5 to 10 minutes to work on it. And then once everybody's completed, if you'll hit play. Okay, so number 1 says, write the standard equation of the circle with the center -3, 5, and radius 2. Hopefully remember from last week that the standard equation is x minus h squared plus y minus k squared equals r squared, where hk is the center, r is the radius. So this would be x plus 3 squared, because it would be minus a negative, plus y minus 5 squared equals 2 squared, which is 4. This one says graph the circle, and the equation is x plus 1 squared plus y minus 3 squared equals 9. So my center, we changed the signs here, so it would be -1 and +3. And the radius, we take that 9 and square root it, which is 3. So my center, I go left 1 and up 3. And then I count to the right, 1, 2, 3, up 1, 2, 3, left 1, 2, 3, and down 1, 2, 3. And then connect them as best as you can with your circle. Number 3 says the line x equals 2 is tangent to the circle in exercise 2. Find the coordinates of the point of the tangent shape. So I pulled in the graph of the circle from example 2, or question 2. And x equals 2 is a vertical line that passes through where x is 2. So right here, we've got our point of tangency, because remember, the point of tangency is where the tangent line touches that circle, and that coordinate point is up to the right 2 and up 1, 2, 3. And question number 4 says the circle has an equation x squared plus y squared equals 4. Determine whether the line y equals -x plus 2 is a secant, tangent, or neither. So again, if we graph this, my center would be 0, 0, because there's nothing after the x or the y. So I put my center here. And my radius would be 2, because it's the square root of 4. So right 2, up 2, left 2. So here's the circle that they're referring to. And it says determine whether line y equals -x plus 2 is a secant, tangent, or neither. So I'm going to plot y equals -x plus 2. My b is the y-intercept, so +2. My slope is -1 over 1. So I go down 1 and to the right 1, down 1 to the right 1 again. And here's my line. Because it crosses through my circle, this is a secant. Okay, so if you haven't already grabbed this document from Canvas, this is called the Chapter 10 Review. If you'll go ahead and open this up, this will help you go through all the topics that we need to cover with some examples built in. That will be on your Chapter 10 test. So that first section, the section over here, kind of puts the vocab from 10.1 and 2 together. So it's not just from 10.1 or from 10.2, it's from both of them together. So if we look at the diagram that's here, the first thing says to name a diameter. So by definition, the diameter is the segment that passes through the center of my circle. So because my center is A, my diameter here would be BC. This is a chord or a segment, okay? So it doesn't have arrows. If you either write it just as BC or BC with a line over it, either way, it's fine. B is the radius. So the radius is a segment that goes from the center to the edge of the circle. Now I could have either done AB, AC, or AD here. So AD, AB, or AC would all be radii. C says to name a chord. So I'm going to pick the one that's just the segment that has the two endpoints on the circle, because that's what a chord is, which is DH. The diameter, BC, is also a chord, but we want to, that's better described as a diameter, so we're going to say that that's a diameter. And then if you look at this segment in here, if we stopped it at FG, that would also be a chord. But again, we're just going to use DH as the example for this one. Then comes the secant. So remember that the secant is a line, which means it has to have arrows when we name it, and it passes through the circle. So there's two lines in this graph. One that's the tangent one on the left there. This here is my secant line. So the name of that line is line FG or GF. Secant would be a line that passes through the circle. E is tangent line. So a tangent line is a line that intersects the circle at just one point. And that would be this line here, which is CB. This tangent is also a line, so it needs the arrows. So CB or BC would be that line. The place where it touches the circle, B, is the point of tangency. So that's a point. A minor arc. So we know minor arcs are less than 180 degrees. We could name a couple of different ways. We could say that BD is a minor arc. We could say that FC is a minor arc. CG is a minor arc. GHB is a minor arc. So there's a lot of different examples in this one. Those would all be minor arcs. A major arc is something that is bigger than 180. So let me clear off some of this stuff on here so we can see this a little bit better. So a major arc, for example, could be CDH. It could be CB, any of those letters. We could go back the other way and say G, as long as we go past half. So I could go to G all the way around to F, or I could go G all the way around to C. All of those are examples of major arcs. A semicircle is one that equals 180 degrees. So this could be like BDC, or CGB, or CHB. Those would all be examples of semicircles. And then also in section, well, that was in section 1, we talked about congruent circles, which are circles that have the same radii, and we talked about congruent circles, which is the ones that look like the bullseye. So these don't have to be the same size, but they do share a center. Okay, so now we get into some examples with some values. So if you look at this example here, it says BAF is 135 degrees. So BAF would be that angle there, 135 degrees, and it wants you to find arc FC. So what we know is that this entire top part is a semicircle, which is 180 degrees. If I take away this 135, what's left over in here is 45 degrees. And the central angle is congruent to the arc. So FC is also 45 degrees. The next one says CAG. So now we're talking about this angle here is 55 degrees. And it wants the measure of arc CDG. So CDG is everything on my circle except the arc that is the central angle, that would match the central angle. So if this is 55, then I would do 360 minus the 55. And 305 would be the measure of arc CDG. Okay, then comes arc BH. So BH is here. And it's saying they BH and HG, actually. HG. Sum to 120 degrees. It wants you to find GC. So again, we've got a semicircle. Down here, this whole thing would be 180 degrees. if we did 180 minus the 120, we get what's left over, which is CG, 60 degrees. And the last example on there says arc BFG. So BFG is 200. And it wants you to find arc CG. Well, I again have a semicircle in here. This would be 180. Take that away from the 200, and that means that there's 20 degrees left over. So CG would be 20. So you would want to be able to find the measurements and also classify them as semicircle major or minor arcs. Okay, then we talked about the theorems in 10.1. So the first one said in a plane, if a line is tangent to a circle, then it is perpendicular to the diameter. So if we look at this diagram that we have done here, if this is my tangent segment, this would be perpendicular to the radius or to the diameter, because the radius would be half the diameter. So there forms a right triangle there if that's tangent. The next theorem said the reverse. If a line is perpendicular to the radius of the circle, so actually let's see, diameter or radius. If a line is perpendicular to the radius of the circle, then it is tangent. So the first example would have said, if this is tangent, then I know this is a right angle. Second says, if this is a right angle, then I know that that's tangent. 10.2 is tangent segments from a common external point. This is that ice cream cone shaped one, and those tangent segments would be congruent. So this segment would equal this segment. Then we got into more chords in 10.3, and the theorem we learned about the chords in 10.3 was if the chords are congruent, then the arcs are congruent. And if the arcs are congruent, then the chords are congruent. So if these two are congruent, then these chords are congruent, and vice versa. If the chords are congruent, then the arcs are congruent. Okay, then came theorems 10.4 and 10.5, which said if a chord is perpendicular to another chord, then it bisects the chord and its arc. So if this is perpendicular, then these two are congruent, as are these two. And vice versa. If those are congruent, then the segments are perpendicular. Theorem 10.6 said if chords are equidistant from the center, then they are congruent. So if we look at this diagram that's under here, we have two chords that are, in order for them to be equidistant, you would have to see little right angles on these, and then these would have to be marked as congruent. So if those are both there, if the right angle's there and the congruency marks are there, then I would know that this chord is congruent to this chord, and the reverse. If those two chords are congruent, then I would know that they're equidistant from the center. Okay, then in 10.4, so in 10.3, we talked about the central angles that we did kind of at the beginning with the example. 10.4, we learned about inscribed angles. So an inscribed angle is one in which the vertex is on the circle, and the measure of the angle is equal to 1/2 the intercepted arc. So if this angle is 20, the arc's 40. If the arc's 40, the angle's 20. We talked about an inscribed polygon. So in this diagram, this quadrilateral is inscribed in the circle. If an angle is inscribed in a semicircle, so here I've got my angle, and the end points of it cut into the two semicircles, which would be the diameter, then the angle is a right angle. Because it would be half of that 180, that's the semicircle. Then came the quadrilateral inscribed in the circle. So if a quadrilateral is inscribed in the circle, then opposite angles are supplementary. So angle 1 plus angle 3 would equal 180. And angle 2 plus angle 4 would equal 180. (10.5) says the angle formed by a tangent and a chord. This is equal to half the intercepted arc. So if this is angle 1 here, it would be half of this intercepted arc. Or if angle 2, let's say, is here, then it is half of this intercepted arc. Then we got into the other kinds of angles, like a floating angle. We kind of called this the floating angle, which is formed by two chords. So if I want to find angle 1, then I add the arc it intercepts plus the arc its vertical angle intercepts. So in this one, it would be arc AB plus arc CD over 2 would equal angle 1. So I add those two arcs and divide by 2. And then we had 3 exterior angles. So if angle here, 1. And each of them are the big arc minus the little arc divided by 2. So if I wanted to know this first one, I would do big arc minus little arc divided by 2. Second one is 2 tangents, big arc minus little arc divided by 2. Last one is a tangent and a secant, big arc minus little arc divided by 2. Okay, then came 10.6, which is all the segments. So we had 3 different scenarios, 2 chords, 2 secants, and a secant and a tangent. The 2 chords, we would multiply. So if this is x, y, a, b, we would say x times y equals a times b. The secants is whole times the external equals the whole times the external. So it would be the whole segment times this external part equals the whole segment times its external part. And the secant and the tangent is whole times external equals tangent squared. So here's my tangent. I would do that squared equals this whole segment times its external part. And we end with where we started at the warm-up, which is the equation of the circles. So remember, the standard equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is my center, r is the radius. So you'll either be given the equation, like x minus 2 squared plus y minus 5, or plus 5 squared, equals 121, let's say. And you have to get the information out of it, that the center would be 2, negative 5, and the radius would be 11. Or you'll be given this information and you'll be getting the equation, or both. So you can get a question in each one. And then we did the graphing. So if you actually graphed, let's say I wanted to graph 2, negative 5, and I wanted to go 11, 1, 2, 3, 1, all the way 11, 11, 11, 11, and then I would connect my points to make my circle. Okay, so that's what's going to be covered on your Chapter 10 test. You can use the rest of the class period. Well, first of all, you're going to turn in these notes and the warm-up in one file. And then you can use the rest of the time to work on the chapter review. And I'll be able to answer any kind of questions you've got on that. Plus the homework that was due this morning, we can go over tomorrow in class. Have a great day, guys.